the life story is about evolution, generation after generation, and normally the next generation does not follow, it takes over. Technology has evolved since the invention of transistors in 1940, and it will continue to evolve. The technology evolution has been almost always inspired by need for more performance or the need for easier way to use the technology. There could be a fantastic technology, but it's extremely difficult to use it. It will not take over. When it comes to cloud, cloud today is not easy to use, and it's not as performant, at least not for the mission-critical applications. The cloud as a technology, you can say it's mature enough that the industry should actually expect a lot from it. It has a lot of promises, and it should be able to deliver on the promises. But when it comes to actually integrating those fantastic features, scalability, flexibility, etc., that we need from the cloud into existing infrastructure of an industry, that's not an easy job. So the industries are facing challenges when they want to cloudify themselves. Now the two basic challenges are performance and lack of ease of use. So the investment to make the things work, to migrate from the legacy environment, legacy application, to the cloud-native application is really a lot. And so that's the inertia for the industry to move toward the cloud. You can ask, why does it matter? We talk about the evolution. Of course, industry is also evolving with the digitalization journey. And digitalization, you can break it down and say, it's about transforming the offering of the industries, transforming the way the industry communicates with their customer, and it's transforming their internal operation to more automated and intelligent operation. For that to happen, you need 5G, you need IoT, you need machine intelligence, all to work seamlessly together. And in a more granular level, you need network devices, application, and cloud to work together. And what is the role of cloud in there? Cloud provides a dynamic, scalable execution environment for the services that are reachable over the internet or remotely available. So you see the cloud is having a very important role in the whole evolution of the industry. And I think that's pretty obvious for everyone. But when I talk about the industry and industrial application, you can question which industry specifically is in need of this. So the question goes, which industry needs to evolve? It is actually harder to find an industry that doesn't need to evolve. So it pretty much goes for all the major industry and even a smaller industry. So you can, it could be dangerous, but you can simplify it, say anyone who has a website is in a way part of the network and benefits from being more digitalized. But when it comes to the application, we can break them down to two big categories. Massive MTC or massive machine type communication and critical MTCs. The massive MTCs are the one that are, you have a lot of small devices, low power, low cost, but each of them maybe generate a small amount of data, but the volume of data is a lot. Like a smart agriculture, logistic, a smart building, you have a lot of sensors across the building. But also, for example, inside the vehicle, you can have a lot of sensors for the function of the vehicle itself. When it comes to a critical MTC, the criticality comes from the consequence of if something goes wrong. So somehow the consequence of difficult environment or failure could be even life-threatening. We are talking about driverless car, we are talking about the health industry, we are talking about big machinery being run by a remote controller, so you don't want anything to go wrong. Those systems are definitely in need of ultra-reliable, very low latency, and also high availability of the system itself. And then the question comes, now we are in the era that we are talking about the edge computing, which category is actually more benefiting more from being at the edge? Maybe you have a guess. Both of them, actually, but maybe for different reasons. What we all know about the edge is good for the low latency. Of course, that's true. So while the machine-critical application benefit from low latency by being put at the edge, the massive MTC will benefit by being at the edge because there is a lot of data that needs to be carried through the network. So it's a network efficiency, operator efficiency. So the machine-critical application being at the edge is good for the user and is a very important part. But having the massive type communication also being at the edge, it's good for the operator and operator efficiency and the network efficiency. So both of them for different reasons. So if you take just one example, this is actually from the real cases that we have done in the industrial collaboration. You have, we are in a manufacturing environment, and there is a robot arm putting the pieces together. And then we are talking about digitalization of this industry. Of course, we talk about 5G, IoT, cloud, and all the pieces needs to be together. But let's just stay focused on the edge. Where is the edge in this picture? If you want to find the edge, find where is the computing in this picture. There is a computing in the robot arm. There is computing in the IT department, maybe behind that door. There is computing that sits close to the IP router and could benefit from interaction with the network, IP network. Computing could sit close to the base station. You can have a dot solution here, and you have the small base station in the basement. It could interact with the radio system. But there is also this whole industry could have its own data center somewhere outside to interact between different sites they have. There is a data center in the country for the regulatory aspect and data privacy in the country. And there is, of course, a global data center. So there are computing everywhere. Where is the edge? So if we go any places that we go from the global data center, we have a definition of edge. In an abstract way being satisfied because you are getting closer to the end user. But there is a reason for computing in different places. So if I just want to picture this in what do we call industrial cloud context, I look at all the computing that is needed for this industry in one big chunk. This is my computing need for this industry. This is my cloud environment. I call it industrial cloud. So it goes from the computing that I have in the device, the computing that I have close to the router or close to the base station, the one at the enterprise data center, all the way to the computing that are in the global data center serving this industry. So this is my industrial cloud. And what is super important for it is that we don't break it down. Because if you have a solution that works super good in that one of the devices, how would it interact with the rest? So I think for one player or one solution, you can have a perfect solution in isolation. But when you put the things together, where the things are starting to become complex and break down. So the reality is like that. Reality, everything has to work together. As I said, there is a different need for the different computing in this corner. The computing that is in the device or the robot arm satisfies the autonomy and extreme low latency. You don't want to have a feedback loop going somewhere else. You want to have it done in the device itself. The one that is on-prem still is autonomy, security, and low latency. The one on the local side, you can have resilience, network efficiency, because you are still closer. You are not going through the entire network. And the one in the country, of course, for the regulatory and compliance aspect. And the last but not the least, the global one for the scale, cost efficiency. So there is a need for all of this. And interestingly, that you may say, no, I don't need all of this in the industry. Yes, maybe in one example, you can skip some of them. But if you want to think about solution as some solution provider, you have to think about the entire context, because you don't want to build yet another solution for another context. So you have to consider the entire scope when building the solution. What is specific about this industrial cloud? So we define industrial cloud, but what is specific about it? If you look at this picture, of course, we already said there are different requirements at different places. That means also different SLAs that has to be satisfied. Different service level agreement in different corners. But also, you clearly see that the computing is distributed. So it's distributed computing, clearly. There is a need for data privacy and security that has to be embedded in the system. There is a network exposure. I talked about having the computing close to the router or to the base station. And the operation of all of this can get very hectic. So automation and autonomous system, you can say, it's extremely important. So in the industry, you want to focus on your application, because your application is the most important part you have. It is pretty difficult to act in that robot application and try to evolve that application. You don't want to get into trouble because the underlying system doesn't work. So that has to be autonomously taken care of as much as possible. So there are some harder requirements on this context than a normal cloud for office application. Cloud. We talk about evolution. So if we say industry is evolving, cloud also is evolving as a technology. What is the cloud evolution itself? Well, on the numbering system, calling cloud 1, cloud 2, cloud 3, the same way that we had on the radio system, 2G, 3G, 4G, we don't have the same standards across the globe. But still, you realize that in the first version of the cloud that we saw, or most of us got to know cloud by that, was virtualizing the servers. And it was a lot of manual work and custom management. But the virtualization of the server was the key part of it. And it was extremely important, a step into the evolution. And then, of course, we realized that manually managing all of those is not as easy, it's not as efficient. Then we came up with centrally controlled services. Now I'm talking about the system like OpenStack, for example. Then you know where are your machines, or how do you generate VMs, etc., and how do you actually build them together. But that also, although it helped the operator of the whole environment a lot, still created a lot of complex management stack. So the stack is getting more and more complex. And for everything that we are missing, we're creating another project, creating another solution, and integrating all of that. Then you need actually an expert to sit and put the things together. But still, that environment, although it has its complexity, was not as useful from the application developer perspective. Somebody who's developing an application on top of the cloud. So you are also familiar with the Kubernetes variant with microservices. So that makes it easier from the application perspective. Still, all of this variant, you need another management system on top of it. So there is a lot of things that needs to be put together by yet another level of orchestration and management, and that creates complexity. And we need to remove the complexity. So we think about the next generation of the cloud to make it easier for data center operator, make it easier for the developer, and look at the pain point that they have today. The data center operator actually doesn't have the visibility in the system. It's actually easy for them to have VM getting lost. So if you have seen some of the solution mapping your logical environment to physical environment, because that's a solution to help you keep track of your stuff in the cloud. So it's the lack of visibility of this old component. And also extremely complex maintenance. It all is dependent on a lot of scripts here and there, and as I said, just one person knows what is there, and if that person has changed job, you're going to have challenge. And also, resource utilization is really not optimal. you have still, we are going with the provisioning as much as we can so to be secure for the future. And then from developer point of view, there is a lot of time that the application developer spend on programming the infrastructure. So if you have the virtual private network and you're actually having a distributed application, you have to program all the details of that. And if you were programming application before, you didn't care about that. You didn't know what is happening in the operating system. That is actually your program is divided to tasks and is assigned to processes, etc. You didn't care. It's just totally separate from you in the normal computer, normal operating system. But when it comes to cloud, we still have the developer taking care of all those infrastructure programmability. So we put some principle in place. If a next generation of the cloud has to come, has to do something that is drastically different. And it has to consider this entire computing system as one big machine. So the operator doesn't have to dig and say, what should I do for this corner, what should I do for that corner? The entire thing is just like one machine for that. And that is important for the operator and also important for the programmer. Think about all the services should be distributed from the beginning, fully distributed. Today, we act on the distributed systems or distributed cloud as we have the central cloud. Now, how do I make it distributed? So I have to put a bunch of them together. How do I orchestrate? Think about distribution from the scratch when you're designing your system. And of course, if you want to, you have a bunch of servers together. Now you want to expand your capacity. That's a big pain today. What about having it organically expand? So as soon as you have a server connected to the bunch of servers that you have had, it will be part of the network. It will be part of the cloud. So organically expanding without needing for any extra configuration. So all of this has to be considered in building the whole platform itself. And also the developer, of course, developer-friendly environment, so they don't have to take care of the things that is not related to the application. They can have their focus on the application, leave all the complexity to the cloud itself. So having all that principle in mind, we go back to industrial cloud and say, what were the real pain points in the industry? We talked about the specification of that, but what are the little bit more granular pain points in the industry? Again, industrial cloud requirements are coming from 5G, IoT, intelligent services. But they are broken down to the concern for data, how the data is collected, transported, stored, taken care of as secure and private. The automation, as I talked about, the automation has to be considered inside, not something as an add-on. Automation should not be as an add-on. Add-on is a complexity, kind of is a remedy for the complexity. Management and orchestration. Of course, these whole pieces of computing should not be the concern of how do you actually put them together. It should be very smooth management of that as well. And then I talk about edge integration. We hear a lot about edge. We talked about edge. We all have an understanding of edge. But actually, integration of that corner that we call edge, wherever it is, with the rest of context is an important part. So if you have a network close by, can you have network exposure? Can you have connection with that? If you have your edge inside the device, do you actually interact with the device and device capabilities? So the actual interaction at the edge sometimes is overlooked. And also network function. So if you have this as part of telecom network, how do you benefit from having the network functions tapping in and giving you more feature and flexibility? So if there are the problems, where are the solutions? Solution can only reside in part of the stack. So we have hardware-driven optimization. We have operating system-driven optimization. I mean, they cannot come from some non-existing place. So it's hardware, operating system, You have application-driven optimization. So for example, if you have a robotic application, there are some specific concerns. If you have an AR, VR application, there are another concerns. So you have to take care of those specific optimization down inside your cloud platform, but also service-driven optimization. This whole context of industrial cloud that we said is one thing to digitalize your industry, but the real hope that you have, you will be able to generate new services very easy, and you want to actually make money out of them. So there is a business relation on creating, there are business services that you want to create, but also you want to have the possibility to connect these services with another business. So if we are, for example, going back to that manufacturing, if you have a specific service there, maybe somebody else needs that service. Why can't you make money out of that? So you have to have business aspect from the service point of view inside your whole platform as well. And of course, is operational efficiency. So I will talk a little bit about this. I will not go too deep. Each of these topics have its own depth and really deserve another deep discussion. But if we talk about hardware-driven optimization, there are a lot of new hardware that are becoming more and more common to use. We had CPUs, but we had the accelerator previously as well in some places. But now we realize that actually accelerators are going to help us with handling a specific workload, but also in that industrial context. Some places you have a lot of processing of data. If you have a VR application, the image that you have in the other side of it, it's pretty big. And handling that is one thing. But also we talked about massive type communication, which is a lot of sensors still that comes to become a lot of data that you have to process. So we are talking about the accelerator, GPU, FPGAs, SmartNIC, etc. But how do we make use of them? So it's good that they exist, but if you want to easily tap into them, you should have a proper abstraction model. Today, still we don't have that, but we are, for example, working on an information model for cloud acceleration to be a service that is already available for industrial context. So that comes the optimization from the hardware place. Then I talked about the distributed has to be inside the core of the cloud itself. So we are thinking about operating system by itself should be distributed. And I talked about organically growing your distributed system. So therefore, your operating system should have that distributed aspect in that. And when we talk about the operating system of cloud, we remove the whole virtualization layer, infrastructure as a service layer, and we directly work on the process level. And in that sense, you can launch a process anywhere that you want, and it will be part of your system. So this is the part that also automation is considered at this. Automation, how do you expand it? How do you manage it? How do you expose your compute services upward? This is from the operating system level. And when it comes to service composition, you have, you know about the blockchain, and it's much more common to see the blockchain concept in the, for Bitcoin and cryptocurrency. But we are using that concept because that's the distributed nature in it. But also we have the security already in a way, to a certain extent, covered inside the cloud platform as well. And that's basically, we use that for the business aspect. We talked about making new business out of new services you are creating. For that, you need authentication, authorization, charging. So we have built a framework based on the blockchain to use it for identity management in the cloud platform itself, but also for all the business-related services. Then, to summarize, I want to say the benefit of cloud are basically, we thought about that. We are trying to cloudify, you have maybe heard cloud native application or cloudified application. And we think that actually operating system of the servers itself is not cloudified. So our approach is actually bringing the cloudification down and build your solution directly in the cloud. And that will lower the development cost because it will be much faster to deploy your application after you have developed them. It will lower your operational cost because there is a high level of automation and some self-configured and self-expansion in the nature of that. And also your resources will be highly used. You don't have wasted resources. And the scalability of it is much easier as well. So to leave you with that, we define the industrial cloud context as something that is absolutely necessary for digitalization of industry, whether it is the first step 5G or IoT. You need to look at the entire context together, computing in different places with different requirements, but the solution has to be holistic. That calls for the engine that is different than the cloud that we have today. Therefore, we have to push to the next generation of the cloud to lower the operational and development cost and increase the scalability. And the optimization resides on the hardware, operating system, application, and service-driven optimization. And there are a lot of material also you can find in the research blog we have. I didn't introduce myself a lot, but my passion for digitalization of industry started when I did my school project. I had to go to a factory, and it was actually fabric factory. And there was somebody sitting and pressing the button and managing the machine. So I created the processor, modeled the processor to how do I automate that manual thing. And that was many, many years ago. So with the same passion, I still think that the industry will evolve to more and more industrial digitalization. Today I have about 70 PhDs working across the board on this topic, and that's the organization that is called Cloud System and Platforms at Ericsson Research. Yeah.